Hey everybody, welcome back. Now if this is your first time, thanks for showing up to my channel. I'm going to do, it's going to be a short video. I'm going to do an update on what my plans are to do the greenhouse rebuild. This greenhouse right here is 8 foot wide, 16 feet long, single layer of 6mm poly on it. Wife, I told her, I said, well, I'm going to make it maybe 10 feet wide and still 16. And the reason is I've got a trailer that I use for a shop parked out behind this. But the wife kept kind of hinting real strong that she would prefer one 24 feet long. So I've got a plan to do that. Right now this is sitting this way. If I turn it like this, which I can do, and pull the trailer up and do a little slight angle on it so I can get the beaver tail down, I can get a 24 foot, basically in the same spot, just at a different angle. So anyway, first things first. Okay, I had said in another video that I had bought these wiggle wire tracks. They're a Vevor brand, which I don't think Vevor actually makes them. Somebody else makes them. I was trying to see if I could get 4 wiggle wires in there. To tell you the truth, you can barely get 3, and that's a tight fit. These are more suited for 2 wiggle wires. So there's another brand that I found that costs a little bit more that will let you do up to 8 layers in there. So that's 8 wiggle wires. So I'm going to be buying 20 of those. I'm going to keep these because I got uses for them. But I just want to kind of touch over that. I can't remember the name of the brand off the top of my head, but I'll put the name of them up here. So what I was thinking about doing too is I got to think about heat. And what am I end up doing? I decided I'm going to put what's called a diesel heater in here. They're now being made a lot for, like, you know, travel trailers and things like that, motorhomes, where you can put these in there and you know, run them off of the fuel that's either you've got or they've got fuel tanks on them. They come in 2 different styles right now, and I'm talking about the Chinese ones now. They come in 2 different styles right now. They come in what's called the all-in-one, and they come in what's called, well, it's not what's called, it's just all the parts are separate, no case. But what I'm going to do here, I'm going to get the one, no case. I'm going to get 8,000 watt. I'm going to put it in here, probably in this one to start with. And it comes with a 10-liter fuel tank. Don't know the math off the top of my head, but I'll put that up. That's like 3-point-something gallons, almost 4 gallons, I think. But I'll put the note up, whatever it is. Comes with that as a separate side deal. Comes with all the other little parts and stuff. So I'm going to put that in here. Now they do have to be exhausted outside. They got a stainless steel exhaust pipe, comes out, goes through the side of the building. And I looked around at different ways of doing that so I wouldn't burn the wood up in the bottom, because as you can see I got a wood base in here. That's what I'm going to do in the other one. And they make a through wall for it, which is actually less hassle for me. I get one for about 20 bucks. Less hassle for me to do that than it is to do all the stuff with the high temperature fiber and all that stuff inside of another pipe. I'd be spending more than I would be for this through wall. And then it has a burn chamber intake air which can stay inside. Then it's got an exhaust and an intake on the inside. You want it inside here. So it's 8,000 watts. So let me give you a little bit of figures here. I got my little cheat sheet right here. So I wanted to compare this. I've got a 3,000 watt Mr. Heater electric that I bought one time for heating the greenhouse. But, you know, electricity has gotten kind of high. And ours has gone up from what it was pre-B. Went from like 11 cents a kilowatt hour. It's up to 13, sometimes 14 cents a kilowatt hour. And the way I calculate that is I look at what the total kilowatts they said I used, and then I look at my total bill, and I do the math, and that's how I come up with it. The actual charge per kilowatt's less, but they got all these extra little fees, you know, in there. So you just take your bill, dollar amount, and your kilowatt uses for that month, do a little math on it, and you come up with the price per kilowatt. So you just divide the kilowatts into your bill, gives you the price per kilowatt. In my case right now, today, price per kilowatt is 13 cents a kilowatt total. So if I take a 3,000 BTU unit, 3,000 watt unit, that's works out to 10,236 BTUs. And at 13 cents an hour, that comes out, 13 cents a kilowatt, that comes out, kilowatt hour, that comes out to 39 cents. 39 cents a kilowatt hour. Tell you what, my hip is hurting me, so I'm going to sit down. Alright, so hopefully you can see me there. I think you can. And hopefully the camera's not too low. I got one where I can't see the screen on it when it's going on. So anyway, like I said, electric at 3,000 watts is 10,036 BTUs and 13 cents a kilowatt hour, because that's what you're billed at on your electric price per kilowatt hour. It comes out to 39 cents per hour to run it. So to run it for 12 hours would be $4.68, and to run it for 24 hours will be $9.36. Now, we're doing this as an assumption that it's going to come on, stay on at the full 3,000 watts, and not turn off within those time periods. Now, granted, if it gets it up to the right temp in here and shuts off due to where I set the thermostat on it, it'll be lower. But I'm doing max out what it costs. But on full blast, doesn't shut down within the time. So 39 cents an hour, $4.68 for 12 hours, $9.36 for 24 hours. Now, if I take the electric and do it at 8,000 watts, and you'll understand why I'm doing that, that's 27,297 BTUs. At 13 cents a kilowatt hour, it comes out to $1.04 per hour to run an 8,000 watts worth of heat, electric heat. So that would come out for 12 hours to be $12.48, and for 24 hours at $24.96. That's a hefty electric bill, people. But now the little diesel heater is also 8,000 watts. So what I'm going to get, you can get a 5,000, but I'm going to get an 8,000. So that I still have the 27,297 BTUs. Now, going at today's price, if I went today and bought it, and where we are, diesel's $4.19 a gallon. So, based off of what the literature is on the heater that I'm going to get, it burns from point whatever to 0.24. I'm going to go back and double check that, but per hour. 0.24 liters, and they give it in liters per hour. Well, you convert that over to gallons per hour for us people in the United States, and that comes out to 0.064 gallons per hour. And that's running that diesel heater full blast at the full 8,000 watts or 27,297 BTUs. Okay, so that comes out to 27 cents an hour. We're already looking at the electric at 3,000 is going to cost me 39 cents an hour. This diesel would cost me 27 cents. If I was using the 8,000 watt electric, it would be $1.04 an hour. So you can see a huge difference in cost difference there. The diesel's cheaper. In the 12 hours, the electric 3,000 would cost, like I said, $4.68. Electric 8,000 would be $12.48. The diesel 8,000 would be $3.22 for 12 hours of run, solid. And at $24, the numbers would be $9.36 for the 3,000 electric, $24.96 for the 8,000 electric, and $6.44 for the diesel. So what that means is that this would burn about 1.5 gallons if it ran full blast for 24 hours. It would do that because, $6.44, and I'm looking at $4.19 for the cost of the diesel. So a little over 1.5 gallons. Now, the greenhouse like this, the one I've got, has got approximately, I forget the square footage area of the film. But for this greenhouse here, with I calculated out, to maintain a temperature of 40 degrees in here with the outside temperature of 28, I would take 6,375 watts power. Okay, or is that BTUs? I'll correct it up in the. I didn't write that down whether it was BTUs or watts. I think it's BTUs. So 6,375 BTUs to do this. Now, this is with a single layer of plastic. When I make the 24 by 10, it will take 9,260 BTUs of heat to bring it from 28 degrees outside to 40 degrees inside. Now, the 6 mil plastic has a heat loss factor of 0.15. If I do like I was talking about and double wall this and inflate it, that drops down to 1.7. So we can look at these numbers and you can easily see that the diesel heater is not really going to have to work very hard at all in here to do it. And so the only drawback with these diesels heaters that you get, the China versions, the controllers that they have different ones, but they all have one thing in common. They never really shut off. They shut off the fuel down to real low or something, but they never really shut off. So you can set it to go down to a temperature and it'll go down and it just really won't shut off. So what I'm going to do is, I won't probably do it initially, is I'm going to install it in here. Then I'm going to put a PD temperature controller in here. And the reason I'm going to use that is because I can dial it down low enough. If you buy just a regular thermostat that you use for like your AC and heat and house, they only go down to like 60 something or 50 something. They don't go, if I want to set it at 40, they don't go that low. But with a PID, PID controller, I can run it down to whatever. I can set it at a minus if I want to. And also they have a remote thermocouple. So I'm going to get one of those, and then I'm going to hook it into the heater and see if I can get it done. Now, some people are using some deals where they open up the little controller and they solder 2 wires on the power button, because you push it and hold it for so long it turns the unit on, push it and hold it for so long it turns the unit off. And that's how they're controlling it with a remote thermostat. But I'm going to experiment to see, well, what if I just kill the power to the fuel pump? Will it continue to run on the fan and not run up with a fault because it says it's out of fuel? That I don't know. Then I'm going to see if I can't just kill the glow plug too, in which case it would go into that. Now the controller will still be calling for it. It would probably go down to slow mode after a little while on the fan. So we're going to look at that. One reason I'm looking at that versus the others, if I wanted to set it up to a higher temperature, the problem with these units is if you turn them off, if you turn them on and you set it to a certain level, and you turn them off and then turn them back on, it loses that, defaults back to the H3, which is about half power, or half heating temp. And so you'd have to have a way to jump it up if you were going to be above that. But we'll see what works. So there again, like I said, I want to keep rambling on here, but that's what we're planning on doing. Planning on going to a 10 by 24 built next year sometime. I'm going to go ahead and get the heater, get it in here, and then I'll start it just the way it is. And they run off 12 volts. So I'm going to get a battery in here and a trickle charger. And we'll let it run off that. And then I've got a lot of updates that I will be doing to the heater install. Won't be doing them in this greenhouse, but I'll be doing them in the 24 when I do that, because I see a lot of efficiency things that I could recapture a lot of heat and utilize it in the greenhouse to help. Every little bit of heat you can get is better. So anyway, we're going to cut this short now. Thanks for subscribing. If you have, if not, please consider subscribing. And also really consider hitting the like button. That helps with the algorithms. I'm trying to build my channel back up again, get it going, and get a lot more subscribers. That's what I'm trying to do, because I'm going to be doing a lot of stuff, people. And hopefully I can get it all filmed and get it out there and make some content that everybody's interested in watching. And hopefully to the end. So thanks everybody. See you in the next one.